Okay, so we're going to talk about translations today, which you guys did really good on, so this is good. Whole bunch of vocabulary, right? So when we begin a new unit, there's always vocabulary. So I kind of changed it to where you're not filling out a lot of the vocabulary. I'm doing a lot of it. So this is what we have. The first word is pre-image, and it's the original figure prior to the transformation. So in my picture over here, here's the picture that we started with. This is my pre-image right here, right? So this is what they started with. And then they did something to it, right? They slid it, they flipped it, they turned it, they did something. So my pre-image is the original image, okay? And then the image is the result of the transformation. So they did something to here. Here's my new image. That's what I'm looking at. And then when they label it, I'm just going to label one corner here. When they label this, this would be A, right, on my pre-image. On my image, it would be called A prime. So if my original points are called A, it would be A, B, C, D, and E. My points on the image would be A prime, B prime, C prime, D prime, and E prime. Does that make sense? Because they can't be called the same thing because they're not in the same location, right? So they have to be called something else. So all they do is they put a little apostrophe next to the letter, so it's something different. Does that make sense? Is everyone okay with that? Okay. Make sure if you have any questions, you can interrupt me anytime and ask questions. That is such a good use of your phone, Camilla, so you can zoom in and see it. So our next word is congruent. That means exactly equal in shape and size. If you notice, these are the same size, right? They haven't changed. It doesn't get bigger or it doesn't get smaller. It just gets moved around. And that's what the word congruent means. It means it's the same shape and the same size. So it means they have congruent sides or segments have exactly the same length. So if we're talking about sides, they're the same length long. Congruent angles have exactly the same measure, so the degree of measure is the same for an angle. And congruent segment sides and angles are often marked. And how they're marked, I'm going to kind of zoom in on that. Here we go, right here. So angles are marked by these little swoops here. So this angle is congruent to this one because they both have one mark there, right? And then my second one, here we go. This angle is congruent to this angle because they have two little curves, right? So it tells you. And then the third one here, there's three little swoops and three little swoops. Does that help a little bit? So when you're marking it up, that's how you can mark it also. And the same with sides here. Let's not do blue. One side here and one side. So those two sides are congruent to each other. And then the double side and the double side is congruent. And the triple and the triple. Does that make sense? So that's how they mark it and how you know which ones are congruent to each other. Okay? So let's go back to here. And so then it says our next vocabulary word, there's a lot of vocabulary, by the way. Corresponding angles or sides. Corresponding sides and angles are pairs of matching angles or sides that are in the same spot in two different shapes. So if I look at my picture, notice that angle A, which is here, and angle X is here. They're the same angle in just two different shapes. Okay, they're in the same place. And then JK here and RS. Now, do the shapes have to be, how do I want to say this? The shape, this triangle here could be flipped the other direction, right? And these two angles would still be corresponding. They don't have to be facing the same direction. Does that make sense? So when the angles could be facing and turned all weird, but still angle A and angle X would be corresponding. Okay? And then the fun one, because this is a hard one, because none of you guys know how to read an analog clock anymore. Who knows what an analog clock is? Yeah, it's the clock like what's up there, right? You guys all have digital clocks now. So clockwise and counterclockwise. Why are you not moving? There we go. So clockwise is the direction that the hands of the clock move, and counterclockwise is the other direction, right? Makes sense? So clockwise, I always have to do it in the air because unless I have a clock, clockwise is this way, counterclockwise is this way, right? So to the right and to the left. That helps out at all. Any questions so far on any of the words? We okay? Awesome. Next. So similar is a little different than congruent. Okay, similar is the same shape, but not the same size. Notice, if you notice that our angles are marked because the angles stay the same if it's similar. Okay, so the angles stay the same. The only thing that changes is the sides, the length of the sides. So it's the same shape, different size, but my angles stay the same. And this is what I was talking about the congruent angles. Corresponding angles, this angle is corresponding to this one. They're in different positions, but they're still corresponding because they're in the same spot, okay? Okay, now let's get down to a translation, which is what we're talking about today. Okay, so each point of a figure is moved the same direction and the same distance, which you guys know, because you did so good on that yesterday when we were talking about when we were doing the Kahoot, right? You were doing great on it. But now we're going to talk about it in a mathematical way. And we're going to talk about how we notate it mathematically and how we figure out what the moves are mathematically. Does that make sense? Okay, so this is what it says. It says, I have a point, some point, x, y. It's some point, right? Doesn't matter, it's just some point. And that point moves to, that's what this x means, this arrow moves, it's moving to x plus a and y plus b. So I'm adding something to x and I'm adding something to y. I could be subtracting, that's okay, that it's a plus. It could be I'm doing something to x and I'm doing something to y. Does that make sense? Okay, so the pre-image and image are similar, okay? Corresponding angles are congruent and corresponding sides are congruent. So technically that means the pre-image and the image are congruent because if the sides and the angles are congruent, then the whole image is congruent. So here we go. We're going to do this. Whew. Maybe you guys can help me with it. What does it say? Can I zoom in? I can zoom in. How much can I zoom in on the iPad is how much is the real question. Okay, here I can zoom in this far and still see on the iPad. Okay, what am I doing to each thing? What does this rule say I'm going to do? What am I doing to x? Does x change or is x staying the same? It's staying the same because I'm not adding anything to x, right? So my x value is going to stay exactly the same. What am I doing to my y value? I'm doing what? I'm taking 3, I'm subtracting 3 from it. So that's what I'm going to do. I'm going to take each one of my little points and I'm going to do this to it. Okay? So it says my x stays the same. I'm going to put this down here. My x stays the same, so, okay, why are you deciding not to write now? Let's pause it for a minute. Okay, so I'm going to take, I guess I won't touch the iPad, and maybe that's what's the problem. X stays the same, that's what it says. It says x is staying the same, so I'm going to put 2 there. And then y, I'm going to, whatever my y value is, I'm subtracting 3. So 3 minus 3 is 0. And you know what I forgot to do? I forgot to rename my point. A becomes what? A prime, right? So this becomes A prime. And A prime is located as 2, 0. Okay? Huh? Because I want to leave it, I want to know that this point is still A, but it's not in the same location, so I have to call it something else. So I'm going to call it A prime. Does that make sense? Okay. All right. So we're going to do the same thing to B and the same thing to C. So B becomes B prime, And B prime is going to be located where? Can someone tell me where B prime is located? What's the X location of my B prime? 3, great. And what's my Y location of B prime? Negative what? Negative 2, yeah, great. Because I take 1 and I subtract 3 from it, right? So 1 minus 3 is negative 2. Awesome. Good job. We're going to get to the graph part in a minute, right? Okay. So now we're going to do C. What does C become? C prime. Awesome. And then what's my X value? 1. Great. And what's my Y value? Negative 1. Awesome. And now we're going to graph it. I love graphing. Okay. Where, and this is where I'm going to ask you guys, where is A prime at? How do I find 2, 0? On my graph, it's okay if I go up this way. We don't need to see we can kind of see it. Where's 2, 0 on this graph at? How do I get there? 2 to the left and the middle, yeah. So I go, the first point, the first number tells me how far to go side to side, right? And the second one tells me how far to go up and down. So I'm going to just draw that over here for you, because I asked that because some people get it backwards, right? So the X value, so if I have my X and my X tells me how far to go side to side, and my Y value tells me how far to go up and down. Does that help? Okay, so that means 2 over, so this is going to become A prime. And then B prime goes 3 to the right and 2 down, right? So this becomes B prime. And then C prime is 1 to the right and 1 down. So that should be C prime. And if I draw my little attempt to draw straight lines, I'm not really good at drawing straight lines, you guys. That kind of looks the same, right? And there we go. It's just translated down 3. And you guys know how to translate the sheet. If I did it just physically, I said slide that down 3. I take each point, I'm going 1, 2, 3. 1, 2, 3. 1, 2, 3. But we did it mathematically instead of graphically. Does that make sense? Okay, so let's do I still need to pause for a second? Some people are already going on to the second one. Good job. Okay, let's do the second one. And number 2 here. Let me slide this up a little bit. Okay, so what does M become? Well, let's go here. What are we doing to X first? We're adding 4. Good. And what are we doing to Y? Adding 2. So we're going to add 4 to every X. And we're going to add 2 to every Y. Do you guys want it? Can you guys try it? Or should I do it? You guys want to try it? Me do it first? Okay. So I'm going to do M prime, right? And M prime becomes negative 5 plus 4 is what? So I have negative 5. So I think of it this way, right? I owe somebody $5. I have $4 to pay them back. How much do I owe them? 1, negative 1, because I owe them $1. Okay? And then I have negative 5 plus 2, so the same thing. I owe somebody $3. I pay them back $2. How much do I owe them? 1. And since I owe, it'll be negative. So that's negative 1. Okay, so then we're going to do A prime. Whew. Okay, so negative 2 plus 4. I owe somebody $2. I have $4. After I pay them back, what will I have? $2, yeah. Okay, so negative 3 plus 2 is what? Negative 1, awesome. Okay, so T prime, negative 2 plus 4. 2, good. And then negative 5 plus 2. negative 3. Beautiful. And then we've got h prime. Oh, negative 5 plus 4, negative 1. And negative 5 plus 2, negative 3. Beautiful, guys. Okay, now we're going to graph this sucker. Put them on the graph, right? Same thing. X goes left and right. Y goes up and down, right? Okay. So negative 1 is here. And that's m prime. And then 2, negative 1, 1, 2, negative 1 is a prime. And 2, negative 3 is t prime. And negative 1, negative 3 is h prime. So there's my lovely little rectangle, my new math rectangle. By the way, I did not make this, so I did not use the word math. Somebody else made it. How was that? Any questions? We okay? Not too bad so far? It's not too bad mathematically, right? Slides aren't too bad. Okay, so let's go to the next one. See what we have. Oh, we're doing the same thing. So guess what you guys get to do? Yep, you guys get to do 3 and 4. Okay, here we go. So I've got, let's see, a prime is going to be 1. And make sure if you have a question or you didn't get the same answer, you ask, okay? 1, negative 6. And if you notice, I'm going to answer all your questions, okay? Even if you ask the same question like 20 times in a row, I'm still going to answer it. And if I get mad, it's because it's not at you guys. Let me go. Okay, so B is B prime, right? And we're adding 2, so that should be 4 and negative 2. And then C prime should be 0 and negative 5. Everyone get those? Is everyone okay with that? Okay, and then we just graph it, right? So negative 1, 2, 3. So that's A. I hope I didn't put that in the wrong space. 2 and 1, I didn't. So that's B. And C is negative 2. Negative 2 and 2, wow, okay, is C. So there's that lovely, whatever we want to call it, triangle. That's what it's called. It's called a triangle, Campbell. Come on. So A is going to be 1, negative 6, 1, 2, 3, 4, 5, 6. So there's my new A prime. And B is 4, negative 2, 1, 2, 3, 1, 2, and there's B prime. Ooh, hold on, 1, 2, 3, 4, 1, 2. How come that doesn't look right? That so doesn't look right. Did I do something wrong? Did I graph it wrong? Add 2, subtract 3. Add 2, subtract, whoa. Oh, that's because I graphed B wrong. Okay. I'm like, what did I do wrong, you guys? Whew. That was close. It should be 2 positive 1 is B. Thanks. See, even I make mistakes. By the way, I make mistakes all the time, so please catch me at it, okay? There we go. Now it makes sense. There we go. And 0, negative 5 should be here, so that should be C prime. And there we go. Questions? I was like, that did not work visually. Okay. So next one is going to be, here we go. Looks like X is staying the same. So we've got 2 and I'm subtracting 3, so that should be 1. F prime is 2, negative 2. And G prime is going to be 4, 1. Okay, I'm going to try and graph this one right. 2, 3, 4, 4, 4, and 1, 2, 1. So I've got E, F, and G. And then we got 2, 1. This should be E prime. And F is 2, negative 2. Wow, I'm just having a rough day. Did I do it wrong? I didn't do it wrong, did I? I'm looking at people. Did I do it wrong? Huh?
What's number 6?
Oh, no, that's F. Wow, okay, never mind. I'm looking at F prime. I thought it was G prime. That's why I'm all confused. See? And 4, 1, 2, 3, 4, 1. I'm like, no. But it's still off. Oh, because I went 4, negative 1 instead of 4, negative 2. Yeah, I'm graphing super well today, you guys. Okay. There we go. Now it looks the same. So this one, I think you guys just had to graph, right? And then it says, what are the, oh, and then I think I just saw you graph because then there's another question. So it says graph it first, right? Translate 4 units to the left and 2 units up. So basically what it wants me to do is do this, right? I'm going to take my x, y, and I'm going to say x is going to the left. Am I adding or subtracting if I'm going to the left? Ooh, question. I'm subtracting, so I'm going to go x minus 4. And y, am I adding or subtracting if I'm going up? Adding y plus 2. So basically that's what they want me to do, right? I want to go 4 to the left. 1, 2, 3, 4. And 2 up should be B prime. 2, 3, 4. 1, 2. A prime. 1, 2, 3, 4. 1, 2. C prime. And then here's my new semi-straight triangle, right? And then they want the coordinates. So I saw everyone draw the triangle in, which was awesome, but there was more directions to the question. So we need to make sure we read the whole question. It says, what are the coordinates of the image? So A prime is, well, we're going to write it out the right way so you guys get used to writing it. So I'm going to say A, where's A located at? A is located at 0, 1. And it goes to A prime, which is located at negative 4, 3. And then B is located at, where's B at? 1, negative 3. Beautiful. And that's going to go to B prime, which is located at negative 3, negative 1. And then we're going to go to C, which is located at, where's C at? 1, 2, 3, 4, negative 1. Which is going to go to C prime, which is located at, oh, C prime is located at 0, 1. Okay? So we just want to be able to know that we can go both ways. I can write it from the equation, and then from the transformation, I can write the equation of it. Because on your test at the end of the year, I hate to keep saying that, they'll ask you questions like that. Okay? Because I don't want you guys to be all stressed. ACT, they probably won't ask questions like that. I can't remember. I have seen a few questions like that on ACT for those of you, those juniors that will be taking ACT. And now they want me to write a rule from R to R prime. So this is how, I'm just going to pick one point. I only need to pick one of them. Okay? And I'm going to write it out. So I think I'm going to pick P and P prime. So where is P located at? 0, 4, right? And that goes to P prime. This is how I do it for me. P prime goes to where? 2, 2? 2, 2. 2, 2. That means I'm going to take X, Y is going to go to, what am I doing to 0 to get 2? What do I do to 0 to get to 2? I what? adding 2, yeah. So I'm going to say x plus 2, right? And now what do I do to 4 to get 2? Subtract 2, yeah. So y, I'm going to subtract 2 from. Done. That's it. So as long as I know how to write my equation, this, I can say, how do I get from here to here? Well, I added 2, right? That's my equation. How did I get from here to here? I subtracted 2. Pretty easy, right? As long as we know how to do this. You guys have worked with this, you know how to do it. So I'm just going backwards, right? Working backwards. Okay, how are we doing on time? Okay. Let's see how much you have. And I know that some of you have already worked on these, so I want you to work on these. If you don't get them, I'm adding 3 to my x, and I'm subtracting 2 from my y, right? So from each point, I'm going to do that. So, so this is the same. I just want to say this. This is the same as if my directions were 3 to the right, and 2 down. So if I get directions to say move my figure 3 to the right and 2 down, this would be what this would. This is what it would look like mathematically, right? Okay. So each point, A prime would be, where's A prime at? 1 plus 3 is 4, and 2 minus 2 is 0. And then B prime would be 1 plus 3 is 4. Great. And 4 minus 2 is 2. And then C prime, 5 and 1. Is that what you guys got? Good. And then we can graph it, right? So I hope I graphed better than I did yesterday. 1, 2, 1, 4, and 2, 3. So that's A, B, and C. Okay, and then we've got 4, 0. 1, 2, 3. 1, 2, 3, 4, 0. 4, 2, and 5, 1. So that's A prime, B prime, and C prime. Is that what you guys got? Nice job. Okay. And if we go to number B, yes, I said number B. In math, letters are numbers, right? Just some unknown number. So I do that a lot, sorry. So number B, I'm adding 2 and subtracting 1. So I've got E prime is 2 plus 2 is 4. And negative 1 minus 1 is negative 2. And then F prime would be negative, great, thank you, negative 2, negative 4. And G prime would be what? 5, 5, 1, good. So we've got 2, negative 1, negative 4, 1, 2, 3, 4, 1, 2, 3. That's F, okay, and 3, 2. Oh, this is a lovely one. Okay, F, G, nope, E, F, wow, and G. Something like that? Okay, so in 4, negative 2, 1, 2, 3, 4, negative 2 is E prime. Negative 2, negative 4 is F prime. And 5, 1, 2, 3, 4, 5, 1 is G prime. So there's our 2 triangles. You okay so far? Not too bad. I'm so glad you guys are doing good with this. Okay, D. Oh, we got more points. Great. Okay. So what is A prime? Good morning. Good morning. Where's A prime located at? Negative 1, 0. Perfect. Okay, where's B prime located at? Negative 1, 2. Okay, and where's C prime located at? I'm sorry? 2, 2. Yeah, good. And D prime is located at 2, 1, right? Sorry. And then we graph them. So 2, 0, and 2, 2, and 5, 2, 1, 2, 3, 4, 5, 2, and 5, 1. So A, B, C, and D. A little trapezoid there, okay? And then we've got -1, 0 for A prime, -1, 2 for B prime, 2, 2 for C prime, and 2, 1 for D prime. So it kind of looks like this, okay? Nice job, you guys. For those of you guys who came in late, did you guys get your little form signed by your parents before I forget to ask? If you did, just get it out and I'll collect it from you. Okay. Don't worry, I'll just keep asking. So you guys will know. I'll just keep asking until you turn it in. Okay? Until you remember to turn it in or get your parent's signature. Okay. So for the last one, what is E prime? 2, 1. Great. What is F prime? 5, 3. And what is G prime? 3, 2. Beautiful. So we've got 2, -2, 2, -2, 5, 1, 2, 3, 4, 5, 0, and 3, -1. Okay, so that's E, F, and G. Oops. Okay, really skinny triangle. And then 2, 1 is F prime. 5, 1, 2, 3 is, that's E prime, huh? E prime. This one's F prime. And then 3, 2 is G prime. Okay. Good? Not too bad. So translations, it's pretty easy, correct? So what will happen is